Hello friends, so today I thought I'll talk about this paper released by Rasa in end of 2018. It's called Few Short Generalization Across Dialogue Task. And the motivation is that in dialogue system, end users can be uncooperative. So for example, if we're training a chatbot on restaurants recommendation, the users can be asking something completely different, like asking for holidays, or they could be asking something more specific, something more general, or they could be changing their mind corrections. So to tackle this, Rasa introduced this architecture called the Recurrent Embedding Dialogue Policy, and they found that it works a lot better than the baseline LSTM model. And the task learn can be used on other domains as well. So for example, back to the restaurant chatbot example, it may be able to use on book recommendations as well. So let's have a look into more detail on how the architecture looks like. In the previous video, we talked about how Rasa, instead of using pre-trained work vector models, because a lot of the English work we actually don't use in dialogue system, so they instead train their word embeddings from scratch by jointly training the words and the intents simultaneously, and then they use a similarity function between states and actions and then rank each candidate and take the one with the highest cosine similarity. So this approach was mentioned in this blog post here, supervised word vectors from scratch. And the idea was based on Facebook's paper Star Space. So in this architecture, REDP architecture, there are a few key steps. So the first step is to featureize the intents and entities extracted by the NLU module, and the slots will be in the form of binary factors. So we talked about previously that the slots are, for example, if the chatbot wants to grab specific information about price, about the type of cuisine, so whenever the users answer those questions, then it will fill in the slots, and then the binary vector will get updated. Then the vectors are then feed into the embedding layers and fed into an attention mechanism where we look at parser, user, and system memory. So in the attention mechanism, it's truncated to only looking at parser, which makes sense because the dialogue, we can't look into the future. So how the attention mechanism helps the system is that, for example, this is the most recent chat, it will get the highest attention. But previous chats, like for example, these ones, the chit chat that are unrelated to the system, ultimate system actions will get ignored. And things that will fill in the slots. For example, I want to place on the 26th of May. This is directly related to one of the system actions that we want to output, so it has received a high attention. Now, the output of the attention now is then fed into a LSTM module, and then we calculate a loss. The loss is calculated by a similarity between the dialogue and our target action, so the things that we want. And we also put in a negative sampling for those dialogues that doesn't use any target action, system actions. So how Rasa go about training is they handcrafted some examples and then compare between the baseline LSTM architecture and then REDP architecture. And the result is dramatic. They can see that the REDP can take actions much quicker, it can identify the correct actions much quicker, and ignores dialogue that are unrelated to the target system action. And they also realized that by training on one specific domain, it can actually do a transfer learning to other domains as well. So as we talked about at the very start, if we train on a restaurant recommendation bot, this trained model can potentially be used, let's say, for a book recommendation chatbot as well. So yeah, I hope you find this brief summary useful, and feel free to check out the paper as well. I'm going to put this in the description below.